Types of choppers based on commutation. I already discussed what is class A commutation or load commutation, and I discussed about class B commutation or voltage commutation. That is also called impulse commutation, and that is nothing but a voltage commutated chopper. I told already, once I am discussing the voltage commutated chopper means the analysis for voltage commutation is also same. No need to remember separately. Similarly, here I am discussing current commutated chopper. I am discussing current commutated chopper means indirectly I am discussing class B commutation or current commutation, or it is also called resonant pulse commutation. That's why it may be commutation circuit or it may be chopper. The analysis is same. Okay, that I told. Okay, now we'll see what is the current commutated chopper. We are studying the current commutated chopper means indirectly how the current commutation we are applying to turn off the thyristor. That concept I am explaining. Yes, I'll have to draw the circuit for current commutated chopper. Okay, this is the circuit we are using for current commutated chopper. Let the supply voltage is Vs. Vs is the supply voltage. And this is main thyristor. This is main thyristor. Yes. And this is capacitor and inductor. Here we are using auxiliary thyristor. TA is the auxiliary thyristor. Let this diode is D2 diode. But here we are using one anti-parallel diode also. And this is D1 diode. Okay. This is auxiliary thyristor. We are supplying the constant current to the load. Load. This I0 is constant. Positive, negative V0. This here we are connecting freewheeling diode. Commutating capacitor, commutating inductor, and this is main thyristor. This is anti-parallel diode. This is D2 diode. This is auxiliary thyristor. Okay. This total circuit is nothing but a commutation circuit. The purpose of using diode later on I will explain. But in the remembering of circuit, to solve the problems, if any circuit is given, calculate current through the main thyristor, current through the auxiliary thyristor, like that it is asked. Then to apply the formulas based on the circuit, how to identify is it a current commutated chopper or voltage commutated chopper. Don't take reference is this diode, you take the reference is this D2 diode. If this diode is present, just for remembering purpose I am telling. Okay, this is not a concept. Okay, for remembering purpose I am telling. If this diode is present, then you take that is current commutated chopper. If this diode is not present, then it is take a voltage commutated chopper. But you don't take this is the reference for to difference which is voltage and which is current commutated. Even sometimes we also use this diode in the voltage commutated chopper also. That is the reason why I am telling that to make the difference, you take the reference is this D2 diode. Now, to explain the operation of the circuit, the assumption is, assume that we are supplying the constant current to the load. Another one is, let already the capacitor charged to a voltage of with a polarity plus minus Vs. Already capacitor is, the initial voltage across the capacitor is Vs, that is plus minus Vs. Sir, how this capacitor is already charged to a voltage of Vs? Don't trigger main thyristor, don't trigger auxiliary thyristor, switch on the supply, then current flowing through this circuit, then capacitor charged to a maximum voltage of Vs, then it acts as an open circuit at steady state, then there is no current. Now the circuit is ready to operate. Now without this circuit, without this anti-parallel diode, what is this chopper, you tell me? One switch and one diode across the load, that is step down chopper. But here which is the device we are using? Thyristor is the device. That's why input is DC supply. If the device is thyristor, in order to turn off the thyristor, we can use some external circuit. This circuit is nothing but an external commutation circuit. And what is this commutation? Current commutation. That's why it is called current commutated chopper. But point to remember, this current commutated chopper is also called resonant pulse commutated chopper. Resonant is also called resonant pulse commutated chopper. That point to remember. It's also called resonant pulse commutated chopper. Because current commutation is also called resonant pulse commutation. That's why it is called resonant pulse commutated chopper. Now see, what is the operation of this circuit? I don't want to draw the equivalent circuit, mode 1, mode 2, mode 3 like that, no need. Just you listen whatever I am explaining operation, we clearly understand. No need to write any points regarding to operation also. Just one statement I want to write. But based on the operation, whatever the points you can summarize, that is important for any commutative point of view. Okay, clear? Yeah. Listen please. Now, to supply the power to the load, now we are triggering the main thyristor. To supply the power to the load, we are triggering the main thyristor. Now tell me, whenever triggering pulse is applied to the main thyristor, it starts the conduction. Yes. Whenever triggering pulse is applied to the main thyristor, it starts the conduction. Main thyristor is supplying the current to the load. This is the direction of current supplied by the main thyristor. The main thyristor supplying the current to the load. This operation is under the assumption of we are supplying the constant current to the load. Now this main thyristor is conducting like this. Okay. Now the question is, whatever I asked in voltage commutated chopper also, if main thyristor is triggered, is it capacitor is discharging or not? That is the first question. As I told already, if there is a path, then the capacitor start to discharge. If there is no path, capacitor will not discharge. It holds the polarity as it is. What do you mean by discharging of capacitor? Transfer of charge from positive plate to negative plate. Yes. Yes, sir. Whenever main thyristor is triggered, capacitor will discharge. If you think like that, this is, if you think this is the path for discharging of the capacitor, this is meaningless. You are thinking like this. Yes, sir, capacitor will discharge us through this path. Like this we are thinking. That is meaningless. We are discharging positive plate to again positive plate. That is meaningless. Discharging means transfer of charge from positive plate to negative. That's why this is not the path for discharging of the capacitor. Yes, this is not the path for discharging of the capacitor. Again, no sir, the capacitor will discharge like this. That is meaningless. Because here diode is present na. Diode cannot allow the current in the reverse direction. That means whenever main thyristor is triggered, for discharging of the capacitor, still we are not auxiliary thyristor. Point to remember. For discharging of the capacitor, there is no path. That's the reason why capacitor will not discharge. Hence, the only current carried by the main thyristor is I0 only. That is, main thyristor will supply only load current. But point to remember, during the conduction of main thyristor, this D1 diode will not conduct. Why? If the thyristor is conducting, there is some forward voltage drop across the thyristor. Let us assume that this is 1 volt or 1.5 volts. This voltage will appear across the diode in which direction? Reverse direction. This voltage will cause the reverse bias of the D1. That's the reason why during the conduction of main thyristor, D1 diode will conduct. This is under off state. During the conduction of main thyristor, because of plus minus this negative polarity, because of this negative polarity, D2 is also not conduct. D2 is also under reverse bias condition. Only main thyristor is conducting and it's supplying the current to the load. The only current carried by the main thyristor is load current only. Whatever the drawback is there in voltage commutated chopper, that can be overcome by using this chopper. Yes. Because where the main thyristor is triggered in the case of voltage commutated chopper, suddenly, instantaneously, how many currents it is carrying? 2 currents. One is capacitor current and other one is load current. But here main thyristor is carrying only which current? Load current only. Yes, that drawback is overcome. Yes. But the purpose of using this circuit is to how this circuit will turn off this thyristor. That concept I want to explain. Okay. We are trigger main thyristor is continuously supplying the current to the load. Then after some time we want to turn off this thyristor. Because if you want to control the power means we don't allow continuous conduction of the main thyristor. We can control on and off. Then after some time we want to turn off this thyristor. Then for that what I can do means I will trigger the auxiliary thyristor. Now whenever auxiliary thyristor is triggered, listen please. Suddenly if the auxiliary thyristor is triggered, suddenly main thyristor will not turn off. If auxiliary thyristor is triggered, suddenly main thyristor will not turn off. Still it takes some time. How it is happening? Still it is supplying the constant current to the load. Now whenever auxiliary thyristor is triggered, now there is a path for discharging of the capacitor. Now what is the path for discharging of the capacitor? And this is the path for discharging of the capacitor. Then during this path, because of this path, then this becomes positive and this becomes negative. Now polarity is reversing. Now during this process, whatever the energy stored in the inductor, that is also transferred to the capacitor. That point to remember. Because of energy stored in the inductor is transferred to the capacitor, in this the capacitor may be overcharged. Because of that overcharging, the voltage in the capacitor is increases. Then because of overcharging, what is the peak voltage in the capacitor? That I want to calculate. Later on I will explain. But point to remember, whenever auxiliary thyristor is triggered, it starts the conduction. Auxiliary thyristor is conducting. Now capacitor is discharging. This becomes positive and this becomes negative. Whenever this is negative and this is positive, auxiliary thyristor is naturally commutated. We don't use another circuit to turn off this thyristor. Like that you don't design the circuit now. Yes. Auxiliary thyristor is commutated. Still main thyristor is not turned off. Now tell me. Whenever capacitor reverses its polarity, this is negative and this is positive. Because of this polarity, D2 diode comes into the forward bias condition. Whenever D2 diode comes into the forward bias condition, now it's supplying the current IC. Now see, now capacitor is discharging through D2 diode. Now at this node, there exist two currents. One is thyristor current, another one is capacitor current, and this current is load current. Can you tell what is the KCL? I0 equal to IT plus IC. I0 equal to IT plus IC. If IC equal to I0, that means if the total current supplied by the load is LC circuit, if this total LC circuit will supply the load current, that is if IC equal to I0, then what to satisfy KCL, what is IT is 0. If IT is 0 means thyristor is turn off. thyristor is turned off. This type of commutation is called current commutation. Simple. Now what I am telling that, now this LC circuit, now the capacitor is discharging through D2 diode. During the discharging of D2 diode, whenever this IC equal to I0 to satisfy KCL, this concept is applicable with the assumption of I0 is constant. Understood? Then IC equal to I0, IT equal to 0, thyristor is turned off. Once the thyristor is turned off, okay, then thyristor is turned off. That point to remember. Sir, okay, for example, let us assume that I0 equal to 10 ampere. Then IT is 2 amperes. Before capacitor is discharging, that is before D2 diode is conducting, what is the current supplied by the thyristor? 10 ampere. Current supplied by the thyristor is 10 ampere. Now whenever capacitor is also discharging, that is D2 is also conducting, now the total current must be equal to 10 ampere. Now what I am telling, now it becomes IC equal to 10 ampere. Now if IC becomes 10 ampere, then what is IT? 0 to satisfy KCL. IT 0 means thyristor is turned off. But point to remember, during this process, if this IC may be greater than the load current, whatever the current is, ICP greater than I0, then that extra current is carried by D1 diode. The point to remember, for example, IC equal to 12 ampere, I0 equal to 10 ampere. Now here which current is entering? IT current. Here which current is leaving? I0 current. Here which current is entering? IC current. Now this is 12 ampere. But the 10 ampere is supplied by capacitor, remaining 2 amperes of current is passing through D1 diode. Understood? During this process. That's why the D1 diode will carry an capacitor current. During discharging of the capacitor, it carries the current. That is important. When the D1 diode comes into the action. Now tell me, if IC equal to I0, IT is 0, then thyristor will turn off. When the main thyristor is turned off, who supplies the current to the load? The LC circuit will supplying the current to the load. The LC circuit, this is the LC circuit will supplying the current to the load. Up to what time this LC circuit will supply the current to the load? That means during the current is supplying, during load current is supplying, the capacitor is discharging. Capacitor is discharging means again this negative becomes positive, then positive becomes negative. Whenever this becomes positive and this becomes negative, with this polarity, automatically D2 is turned off. Already main thyristor is turned off. This circuit is also not supplying load current. Then to supply the constant current to the load, then which device comes into the action? Yes, freewheeling diode comes into the action. Now freewheeling diode will supply the current to the load before coming to the main thyristor. This is as it is first case, as it is first case. Then as it is first case means again you can trigger which thyristor? Main thyristor. Then main thyristor will supplying the current to the load. Now main thyristor will supplying the current to the load now. Now what I can do means, now I will trigger the auxiliary thyristor. Whenever auxiliary thyristor is triggered, this becomes negative, this becomes positive. Now with this polarity, again D2 diode is conducting. If D2 diode is conducting, whenever IC equal to I0, then main thyristor will be turned off. If there is any extra current is there, that current is carried by the D1 diode. That current is carried by the D1 diode. Understood? Now whenever this, now again polarity changes to negative becomes positive, positive becomes negative. Then automatically D2 diode will turn off. Now which device will come into action? Freewheeling diode. Like this process will be continued. Understood? In this circuit, how this circuit will turn off the main thyristor? This circuit will turn off the main thyristor by making IC equal to I0. If the total capacity, if the load current supplied is equal to capacitor current, then there is no current through the main thyristor, then main thyristor will be turned off. This type of commutation is called current commutation. Understood? Okay. That means this you know down. If I0 equal, where I0 equal to IT plus IC, If IC equal to I naught, IT equal 0, then thyristor will be turn off. Okay. Now, this operation is not important. Based on this operation, some points I want to list out that is important for commutative point of view. Now, tell me. What is the peak current through the main thyristor? What is the peak current through the main thyristor? The main thyristor supplying only load current. That is peak current through the main thyristor. These points you list out. Peak current through the main thyristor. Peak current through main thyristor. ITMP equal to I naught. Tell. Next. What is the peak current through the auxiliary thyristor? This auxiliary thyristor is conducting which circuit? LC circuit. That's why in LC circuit, what is the maximum current? Vs into square root of C by L. That is peak current through auxiliary thyristor. Yes. Peak current through auxiliary thyristor. Parallelly note down peak current through auxiliary thyristor. Auxiliary thyristor. How much? ITAP equal to Vs into square root of C by L, because it's supplying the current in LC circuit. The peak current through auxiliary thyristor equal to Vs into square root of C by L. Correct? Next. Tell. What is the peak current through D2 diode? D2 diode is also carrying LC circuit current, and that current is equal to which current? Load current. That is peak current through D2 diode. Peak current through D2 diode. D2 diode. ID to P is equal to I naught, and it is also equal to Vs into square root of C by L. Next. What is the current carried by the D1 diode? The current carried by the D1 diode equal to IC minus I naught. IC will supply I naught, remaining current is carried by the D1 diode. Next. I told, during conduction of auxiliary thyristor, whatever the energy stored in the inductor, that is transferred to the capacitor. Because of that, the capacitor is overcharged. Then what is the peak voltage across the capacitor? Now there is energy transfer. What is the energy transfer? Half CV square equal to half Li naught square. Then due to transfer of energy from inductor to capacitor, what is the rise in voltage of the capacitor? The rise in voltage of the capacitor V equal to I naught into square root of L by C. This is the rise in voltage in the capacitor. Already what is the voltage across the capacitor? Vs. Then what is the peak voltage across the capacitor? The peak voltage across the capacitor is Vs plus I naught into square root of L by C. Okay. Because of energy transferred from inductor to capacitor, this much of rise in voltage is present in the capacitor. This is the peak voltage across capacitor. Peak voltage across capacitor. This is the peak voltage across the capacitor. Okay. Listen please. Now, with this knowledge, the same concept can also explain by drawing the waveforms also. After drawing the waveform, I want to write some more formulas also. That analysis, some more analysis I want to explain. Okay. You draw the waveforms based on this operation. Okay. Concentrate. Yes. Draw the waveforms. Based on this analysis, how to draw the waveforms. Yes. This is triggering pulse is applied to main thyristor. And this is the triggering pulse is applied to auxiliary thyristor. And we are assuming that load current is constant. I0 is constant. Let this is current through the main thyristor. Current through the main thyristor. Let this is IC waveform. This is IC waveform. And let this is voltage across the capacitor waveform. We are assuming that we are supplying the constant current to the load. Throughout analysis, load current is constant. This I0 remains constant. Okay. Now, here main thyristor is triggered. This the triggering pulse is applied to the main thyristor. Yes. When our main thyristor is triggered, it's applying the current to the load. It's applying the current to the load. And during the triggering of main thyristor, there is no any capacitor current. Capacitor current is 0. Capacitor is not discharging. Yes. That at this instant, we are trigger auxiliary thyristor. At this instant, we are trigger auxiliary thyristor. We are trigger auxiliary thyristor. This is a triggering pulse is applied to the auxiliary thyristor. Now, whenever auxiliary thyristor is triggered, the capacitor starts to reversing its polarity. Before triggering of auxiliary thyristor, what the voltage across the capacitor? The voltage across the capacitor is Vs. Before triggering of auxiliary thyristor, initially voltage across the capacitor is plus minus Vs. This is Vs. Now, the capacitor is up to this capacitor current is 0. Now capacitor is discharging. Discharging means we can draw the negative current waveform. Negative. Still main thyristor is conducting. Still main thyristor is conducting. And this is the capacitor current waveform. After fully discharging the, after completely reversing the polarity, then the capacitor current becomes 0. Then it is again after capacitor current is 0. Here auxiliary thyristor will be turned off. This becomes minus. This becomes plus. But again capacitor is discharging because suddenly which diode will comes into the action? D2 diode. Then again capacitor is discharging. Then because D2 diode. At this instant, beyond this instant, from this instant. Here the capacitor current is 0 from this instant. Then capacitor current is, the capacitor is supplying the load current. Capacitor is supplying the load current. Then what are the thyristor current? What is the main thyristor current? Slowly decreasing. Whenever capacitor current is equal to load current, capacitor current is equal to load current, this is equal to I naught. If the capacitor current is equal to load current, then the main thyristor current falls to 0. That is, main thyristor will be turned off. At this instant, IC becomes I naught. Then main thyristor is, current is falls to 0. Then again, capacitor is slowly, after reaching the peak value, because it's a LC circuit now. In LC circuit, what is the nature of the current? Sinusoidal oscillations. After reaching the peak value, this current is, after reaching the peak value, again it is falls to 0. Like this we can get the wave shape. Okay. Now here the capacitor is discharging. Capacitor is discharging. It is changing from plus Vs to minus Vs first. Plus Vs to minus Vs. It charges to maximum value. Then again it changing polarity from minus Vs to plus Vs. Minus Vs to plus Vs. Minus Vs to plus Vs. Like this you can get the wave shape. It falls to Vs. Then capacitor voltage is reaches to Vs. Whenever capacitor voltage is reaches to Vs, the current falls to 0. The capacitor current falls to 0 because it is completely discharges. Completely reverses its polarity. Then it becomes again plus Vs. Sorry. You can get like this. This is Vs. This is Vs. Again it falls to Vs. Okay. Like this we can get the wave shape. Okay. Yes. We take this one. 1 minute please. During, let this instant is t equal to 0 instant. This is t1 instant. This is t2 instant. This is a t2 instant. And this is t3. And this is t4. Yes, this is t4. Take this is t4. Okay. 1 minute please. Here capacitor is discharging. Whenever auxiliary thyristor is triggered, capacitor is changing its polarity. That is from minus plus Vs to minus Vs. Plus Vs to, it changing from minus plus Vs to minus Vs. Whenever it is completely plus Vs to minus Vs, then capacitor current falls to 0. But again it is not holds the voltage stationary, because at this instant suddenly which device comes into the action? D2 diode. Once the D2 diode comes into the action, this diode, D2 diode comes into the action, again changing in opposite. Again it is charging from minus Vs to plus Vs. During this minus Vs to plus Vs, whenever IC equal to I0, the capacitor is, whenever IC equal to I0, the main thyristor current falls to 0. Main thyristor current falls to 0. That means from this instant, at this instant, from main thyristor current falls to 0 to up to some time, T4 time. This time is generally taken as a circuit turn off time, because during that time a reverse voltage is applied across the SCR, main thyristor. Okay, again it is reaches to Vs now. Neglect these oscillations. Okay, neglect this transient voltage, all this. There is some transient effect, again there is some transient effect, all this. Neglect that one, because of presence of inductor and because we are sudden switching of inductor capacitor like this, there may be presence of transient currents and transient voltages, no doubt at all. But point to remember, from T3 to T4, the thyristor is reverse bias. Again the capacitor voltage reaches to Vs now. Capacitor voltage reaches to Vs. Now this device is ready to trigger. Now whenever it is plus minus Vs, ready to trigger means now it supplies the load current. Understood? Now this T3 to T4 time is taken as a circuit turn off time. This time is taken as circuit turn off. What is total time, you tell me? In terms of angle, you tell me. This is pi, because half cycle. Let I am assuming that this angle is theta, and I am assuming that this angle is also theta. Then the circuit turn off time is this one. In the total pi, you subtract theta, then that gives the circuit turn off time. Let this voltage from T3 to T4 voltage, let this voltage is any voltage, you take the VAB from point A to point B. This voltage I taken as VAB, that is the voltage applied across the device during reverse bias condition. During that time is taken, the reverse voltage applied across the device under reverse bias condition, whatever the time is taken, that time is called circuit turn off time. Okay, from that I want to write some analysis. This over now? Yes, clear? Okay, now tell me. You want to do some analysis here? Yes. What is the circuit turn off time, you tell me? The circuit turn off time equal to T3 to T4, that is T4 minus T3. T4 minus T3. In terms of angle, omega naught Tc equal to pi minus 2 theta. Then from this, what is Tc equal to? Pi minus 2 theta by omega naught. This is the circuit turn off time. Okay. Now, this one equation you remember. This is a circuit turn off time equal to pi minus 2 theta by omega naught. Then what is omega naught here? Omega naught equal to 1 by root LC. If IC equal to I naught, then if IC equal to I naught, then whatever the thyristor is commutated. Thyristor is TM is turn off. TM is turn off. In terms of IC means, then how to write? IP sin omega naught T. IP sin omega naught T. Or that is equal to ICP sin omega naught T. Sin omega naught T is equal to which one? I naught. Let this omega naught T equal to theta. At this instant only thyristor is turn off now. At IC equal to I naught, thyristor is turn off, that angle is taken as a theta. Okay, shall we write like this? That is sin theta na, IP or ICP into sin theta is equal to I naught. From this, what is theta equal to? Sin inverse I naught by ICP. Theta equal to sin inverse I naught by ICP. Let this is equation 2. But you know that what is IP or ICP in LC circuit? Vs into square root of C by L. And let the ratio X equal to ICP by I naught. Let X equal to ICP by I naught. If X equal to ICP by I naught means then what is theta equal to sine inverse 1 by X. Sine inverse 1 by X. Let this is equation 3. Sine inverse 1 by X. Now from this what is the circuit turn-off time? Circuit turn-off time equal to pi minus 2 into sine inverse 1 by X by omega naught. How to write omega naught equal to pi minus 2 into, this I am substituting here, pi minus 2 into sine inverse 1 by X into omega naught is root L. 1 by root LC na, that is root LC. Then from this what is root C equal to TC by root L into pi minus 2 into sine inverse 1 by X. Okay, this is root C. Listen please. What is ICP equal to ICP equal to? ICP equal to Xi naught, that equal to, we know this. IP equal to ICP equal to Xi naught Vs into square root of C by L. Vs into square root of C by L. Okay. Then substitute root C in this equation. Let this is equation. Root C in this equation. If you substitute root C in this equation, then we get the expression for L. That is by solving this equation, by solving these two equations, then I will get the expression for L. What is the expression for L equal to? VL equal to, then expression for L equal to means what we can get? The expression for L equal to Vs into Tc by Xi naught into pi minus 2 into sine inverse 1 by X. This is the commutating inductor. Similarly, you can get the expression for C equal to Xi naught Tc by Vs into pi minus 2 into sine inverse 1 by X. This is the design of commutating inductor and commutating capacitor. L equal to Vs into Tc by Xi naught into pi minus 2 into sine inverse 1 by X. This equal to C equal to Xi naught Tc by, what is the Tc here? Circuit turn-off time, pi minus 2 into sine inverse 1 by X. This is the commutating inductor. And this is the commutating capacitor. Like this we can, by solving these two, we can get these two expressions. What the commutating inductor and the commutating capacitor formula. See, one more formula I want to write. IC equal to C into dV by dt na. From this, at IC equal to I naught, C into voltage applied is VAB. This time is taken as circuit turn-off time. Then circuit turn-off time equal to C into VAB by I naught. Like this also we can define. During this TC time, the voltage applied across the thyristor is VAB. That's why written TC equal to C VAB by I naught. Okay, let this is equation 1, equation 2, equation 3. Then by solving these two equations, this we are getting equation 4 and this is equation 5. Let this is equation 6. These formulas you remember. This is with respect to which chopper? Current to commutated chopper. IC equal to C into dV by dt. That is, you want to C means Xi naught Tc by Vs. Okay, these points you remember. But point to remember, what is the purpose of using anti-parallel diode? Because of this anti-parallel diode, during the conduction of D1 diode, this voltage will appear across the main thyristor as a reverse voltage. But how much? If you take the 1 volt 0.5 volts drop or 1 volt drop across the diode, that voltage will appear across in the reverse direction. That will cause us the commutation of the main thyristor also. But that 1 volt will cause us for turn off of the diode, it takes more time. That's why, because of anti-parallel diode, very important point, due to this point you write down, due to anti-parallel diode, the turn off time is increases. But advantage is turn off power losses will be reduced. Because of anti-parallel, because voltage drop is very less now, that's why turn off power losses are reduced. Turn off time is increases, but turn off power losses is reduces. Due to this, turn off time is increases. Turn off time increases due to anti-parallel diode. Turn off time increases, but turn off power loss reduces. Turn off power loss is reduces. Loss is reduces. Turn off time is increased, but turn off power loss is reduces. But what is the average output voltage in the case of current commutated chopper? The theoretical value or practical value, both are same. That's why in the case of current commutated chopper, the average output voltage V0 equal to dVs only. It is similar to that of which one? Step down chopper. Either theoretical values or practical values, we are getting same values, no difference. Then V0 equal to dVs. That formula you remember. The one more point to remember, as compared to, that is, as compared to voltage commutated chopper, this current commutated chopper is more advantage, because the peak inverse voltage across the freewheeling diode is Vs only. The peak inverse voltage across freewheeling diode is Vs only. And the peak instantaneous voltage across the load is also Vs. But in the voltage commutated chopper, that is 2 Vs. And another advantage is the capacitor will charge more effectively. Because of overcharging of the capacitor, we can effectively turn off the main thyristor. This is more effective commutation as compared to voltage commutation. But among all the commutations, which is the more effective commutation means this current commutation is more effective commutation. That point also you remember. Okay. One more point. One of the main application of current commutated chopper means this chopper is used in the traction cars. Okay, because of effective commutation and because of effective control, this chopper is used in the traction cars. In the traction cars, we are using this chopper. Current commutated chopper is used in traction cars. That point also you remember. Clear? Okay, this about in detail about what exactly current commutated chopper. This I am telling that you substitute root C here, then you can get the expression for L. Substitute expression for L in this equation, then we can get the expression for C. Like that we can solve. Once again, substitute root C here, that root C formula. From that we can get the expression for L. Substitute L in this equation, then we can get the expression for C. By solving these two, we can get L and C, commutating inductor and commutating capacitor. Clear? Okay, no doubt. This about in detail about what exactly current commutated chopper. Then next session we will continue with another type of chopper, that is nothing but a load commutated chopper. I discussed current commutated chopper means I discussed about current commutation. I discussed voltage commutated chopper means I discussed about class D commutation. That is voltage commutation. Class D commutation is completed. Class B commutation is completed. Class A commutation is also in the first session in this concept I discussed. Then in the power semiconductor devices explanation, I already explained classes. A remaining commutation method is C and E. Before discussing C and E commutation, first I will discuss load commutated Jones and Morgan chopper. At the end, remaining commutation I will complete. Okay, the next session will continue. Thank you.